When we first heard of conditional probability, we generally thought of the probability of a later event given that an earlier event occurred. Okay. Now we're going to talk about the probability of an early event given that a later event occurs. And by early and late, we don't mean time points, but rather locations in a probability tree. Let's see how this works by doing an example. So we've got a box with 4 white marbles and 3 red ones. We're going to draw 2 in succession without replacement. So let's draw a picture of our box. Okay, 4 white marbles, which we'll indicate by W's, and 3 reds. What can happen? Okay, on the first draw, we can get a white, or we can get a red marble. And on the second draw, we can get a white, or a red, a white, or a red. Let's put our probabilities onto our tree. What's the probability of getting white on the first draw? Well, we have 7 marbles altogether. 4 are white and all are equally likely, so 4 sevenths would be our probability and 3 sevenths for getting a red. Now, if we get white on the first draw, then one of these is gone because we are not replacing the marbles after we draw them. So now we have 6 marbles in the box. 3 are white, 3 are red, so that gives me 3, 6, 3, 6, and we can simplify these if we wish. Okay. Now, what if we get a red marble on the first draw? Okay, so now this white marble is back in the box, but one of the red ones is gone. So now we have 6 marbles. 4 are white, which will give me 4 sixths, or 2 thirds, and 2 are red, so 2 sixths, or 1 third. Now we apply our conditional probability formula. First, we need to decide what we are being asked for. The probability of drawing a red marble on the first, given that a red is drawn on the second. So what do we know for sure about what happened? Well, we know for sure that red occurred on the second draw, and so then we're trying to figure out what's the probability that red occurred on the first. Remember, the given always follows the vertical line. Now, what does our formula say? Conditional probability, the formula, the definition of it says that it is going to be the probability of the intersection divided by the probability of the given. Probability of the intersection divided by probability of the intersection. So now we just need to figure out what those are. So to get the intersection, okay, that means it's going to have to go through R1 and also R2. So that's going to go through R1 and also R2. So we find the branch of the tree that goes through those. Okay, so our intersection, our numerator then will be 3 sevenths times 1 third. Okay, our denominator is what? Our denominator gives us all the ways, we need to take all the possible ways that we can obtain R2 and add them together. So how on our tree can we get to R2? We can go this way, or we can go this way. Those are both ways of obtaining R2. So 4 sevenths times a half plus 3 sevenths times 1 third. Now we simplify. This will be 1 seventh over 2/7 plus 1/7 which is equal to 1/7 over 3/7, which is 1/3. And that is the probability that we're being asked for. Okay. So what we really just used was something known as Bayes' theorem or Bayes' formula. You don't need to memorize it because it is just the conditional probability formula that we already know. It is nothing more. Probability of A given B is equal to the probability of the intersection divided by probability of the given. If you want to think about it as a formula, you could write it out in words and say that the probability of the early event A, given that the later event B has occurred, is the product of all the probabilities on the path to B through A, and the sum of all the divided by all the sum of all the branch products leading to B. You can think of it that way. Really, you just want to think of it as the conditional probability formula. That's all it is. Let's do another example. Okay, so we've got a television manufacturer that is manufacturing picture tubes in 3 locations. Okay, so A, B, and C. We're going to make ourselves a probability tree. Okay, so each of these 3 plants, A, B, and C, produces some defective picture tubes and some not defective. Let's write ourselves what we're going to define D to be. We'll define D, to be defective, and therefore D complement is not defective or good, right? They work okay. So each of these can make both types of TVs, defective and non-defective. We're going to have a probability for every branch along this tree. Okay, what's the probability that a given television comes from plant A? Well, 50%, so 0.50. Remember, our probabilities are not percentages, but numbers between 0 and 1. B will have 0.30. C will have 0.20. In case you're not familiar with the way this word respectively is used when you see a problem like this, what that means is that the order is in the same for both things listed. In other words, A, B, and C are listed in this order. The respectively means that the 50, 30, and 20% apply in the same order. In other words, the 50% goes to A, 30% applies to B, and 20% applies to C. So that's how we get our probabilities for A, B, and C. Now, what's the probability that a given TV from A is defective? Well, 1% of the picture tubes produced by A are defective, so that'll be 0.01. And so then how many, if 1% are bad, how many are good? 99%, or 0.99, then will be the probability. Moving on to B. 2% are defective. We subtract from 1 to get the complement, so 0.98. The same for C, it looks like. Okay, now we need to figure out what we're trying to find. Okay, so look for where it is asking you a question. If a Pulsar 19-inch color TV is selected at random and the picture tube is found defective, what is the probability that it came from plant C? Okay, so we need to fill in the blank here, what we're trying to find. Okay, what do we know? Is there something we know for sure about this TV selected at random? Yes, we know that the picture tube is found to be defective. So the D is given. Okay, now what are we trying to find? We're trying to find the probability it came from C. So that's going to go here. Remember, your D your given always follows the vertical line. So the probability that came from C, given that it's defective. Okay, what's our definition of conditional probability? The probability of the intersection divided by the probability of the given. Okay, so to find the probability of the intersection, we need to figure out what path it goes through both C and also D, because both of those have to occur, or intersections, so that goes through C and D. And so how do we find the probability of that? We multiply along the tree. So 0.20 times 0.02. And now we need to find the probability of D. So now we find all the ways that it's possible to get to D. There's 3 ways to get through D. That's one way to get to D. We can also go through B to get to D. We can also go through C to get to D. Okay, so we're going to add up the products along each of those branches. So 0.5 times 0.01 plus 0.3 times 0.02 plus 0.2 times 0.02. And when you work all this out, you should get 0.004 divided by 0.015, which is approximately 0.2667, rounding to 4 decimal places. Okay, I hope this helped you to understand Bayes' theorem and how it's really just the conditional probability formula and nothing more. Good luck!